Hello, students. Today, in our topic, we are going to discuss about motion in a straight line. This is actually class 11 syllabus, and we are going to discuss some definitions and some introduction towards the straight line motion. Okay, see what is actually the motion? Motion of an object. See, in the universe, everything is in motion only. Okay. Some objects may appear to be at rest, but in actual scenario, every object is in motion only. The motion is a relative thing. It's compared to some other frame of reference or some any other object. So here the motion in a straight line. So a straight line motion is a one dimensional motion. Okay. So if we able to study the motion of the objects in the universe, so we will be able to get the idea of the universal laws by studying the motion of the objects in the universe and space. Okay. So here the motion without studying the cause of motion is called kinematics. Okay, kinematics is also called in the name of motion in a straight line. Here we study only the pure motion of an object without considering the cause of the motion. It may be caused by any force or something else, but we don't consider as of now. We are only considering the study the motion of the object in a straight line. Okay, see here in kinematics, the straight line motion is also called a rectilinear motion. Okay, when an object is moving in a straight line motion, when we can say, see, when an object is moving from one point to another point, if the successive points in the motion, that means if an object is moving from A to B, right? A to B. In this motion, the successive points, which successive points means the points through which the body is moving. If the successive points are connected, then the line joining all the successive points is a straight line. If the line joining all the successive points of the path of the body is a straight line, then it is called a straight line motion. Okay. So here we will mostly study the straight line motion of an objects, and this is a one dimensional motion. Later we will go to two dimensional motion, that is called motion in a plane. As of now, how to consider and how to study the motion of objects in one dimensional. Basically, I told you the motion of objects is a relative thing. If some object is in motion, it should be compared with some object either at rest or at motion, then this can be said this is in motion. That is the actually the motion representation. Okay, if we have taken that we are at rest, we are sitting in a chair, suppose we say we are at rest, compared to what? Compared to the, if you take the reference point as in earth, compared to earth we are at rest. But when we take a reference point as moon, compared taking a reference point on the moon, our we are not at rest, we are moving only, because we are on the earth and the earth is revolving continuously, and it is also are continuously revolving around the sun. So the motion is a relative thing, the movement of any object is a relative thing. So to study that relative thing, we need to consider a frame of reference. See, to study any motion of object, we need to consider a frame of reference. What is a frame of reference? See, if an object is placed at some point in space or anywhere, how to consider that, how to locate that point in space? So for that, we consider a rectangular coordinate system to locate the point, so that by locating that point, if the object moves from that point to another point, so we can track the motion of the object with this frame of reference. So the reference means we can refer the object where it is, that is frame of reference. So in this we can say, we can draw a frame of reference like this. See, this is, and this is actually a z axis which can be written on this board like this, but the axis will be like this, perpendicular to this x axis and y axis. Okay, with this kind of a rectangular coordinate system, imagine this z axis will be in this form, perpendicular to this board, but we cannot write like that on the board, but that's why I have written that z axis in this direction. So this kind of coordinate system will locate an object or a point, okay, where it is and from where it is moving to another point. So this is the frame of reference. And one more thing to add this to this frame of reference is the time. So motion is a time bound activity. See, if this object, an object has moved from in this coordinate system from this point to this point, A to B, okay, so in the time frame of suppose t seconds, then we can say the object has moved from A to B in a time frame of t seconds. So if we add some time in the form of a clock, a time clock added to this frame of reference, is together is called a frame of reference. Okay, so the coordinate system with a time reference, a time clock, is called a frame of reference. See, generally an object is considered as a point object only, whether it is moving in space or anywhere. When it is considered a point object means the distance traveled by the object when compared to the size of the object. The distance traveled by the object when it is compared with the size of the object, the size of the object should be very small comparison to the distance covered. So then only we can consider the object as a point object. Okay, see, this is the frame of reference. Next thing, we will go to what is the rest and motion. The terms rest, comma, motion. See, when an object is said to be at rest, an object is said to be at rest when it is not covering any distance with respect to the coordinate system and with respect to time. So then it is said to be at rest. And the same thing when an object is covering a distance, traveling a distance and moving in the coordinate system between two points with respect to time, then object is said to be in motion. Okay, then next term, the position, comma, path length. Position, comma, path length. So what is position? I told you the position of an object is referred with the help of a frame of reference. So if we consider the position as x, y, z, the x, y, z are coordinates of reference frame, and then the position of object is referred with this coordinates, okay, x, y, z, and there will be another coordinate which is time, and we don't show in this system, only these are the position coordinates. So this is the position coordinates are taken from the origin as a reference point, okay. What is the path length? Path length is the distance traveled by or covered by an object while moving from one point to another point in a coordinate system. The distance between the 2 points is called the path length, okay. So the path length, in this lesson we will consider it in two ways, okay. The path length, the distance traveled by a point from one point to another point. See, I have seen, I told you that in a coordinate system, if an object is moving from A to B, so if these are x1, y1, z1 is the initial position coordinate, and x2, y2, z2 is the final position coordinate, then the distance traveled from A to B, or the difference between two position coordinates, is called path length. So what is called path length? The first definition, it is considered, I told you that it is considered in two ways. The first one is the path length is can be considered in a way of displacement, okay. This is also called distance. Path length is also called distance also. So what is displacement? Okay, displacement is considered to be the shortest possible distance between the initial and the final position of the body when the body is moving from A to B, or this A is considered as initial position and B is considered as final position. So the what I am telling is your shortest distance. See, this is not the actual path followed by the object. The shortest distance, that means if we take an example, suppose an object is moved from A to B. The path followed by the object is, suppose this is the path. The path length is the total length of the path, the actual path. But the displacement is not the actual path. See, the shortest distance possible. How can you write the shortest distance? It is the straight line connecting these 2 points A and B is the shortest possible distance. Is there any other way to find the shortest possible distance? No. This is the shortest point. In this way, the displacement can be defined as the shortest possible way, possible distance possible between A and B. Okay. To understand it better, we will take an example for displacement. Okay. So here the distance and displacement both are the distance covered by the object only, but the distance has a meaning of actual length covered by the object, and the displacement is the shortest distance between the 2 points, initial point and final point. See, I will tell you with an example. If a body is moving, see, from this point, if you calibrate this x-axis into meters, suppose 100, 150, 200, it is in meters. So now if an object is moving from 0 to 200, meters, covered a distance of 200 meters. It is moving in this direction. Okay, initially it has started here, it is moving towards this point, and again after coming to this point it has returned and stopped here. Okay, it is up to here, and at this point it is returned and it is stopped here at this point. So if this is the initial point A and this is the final point B, okay, so this is the initial point, this is the final point. Then in this case, what is the distance or path length and what is the displacement? See, the total length covered by the object is A to this point, 200 meters point. The length is 200. So we can write the distance as from here to here 200 meters plus from here to here, actually the object final point is and it has stopped at this point. From here to here, what is the difference? 50 plus 50. So total distance covered is 250 meters. Okay. Now what is the displacement in this case? Displacement means, I told you that the shortest possible distance between the initial and final point. This is the initial point and this is the final point. The shortest possible distance is, from this scale you can tell, 150 meters. So here we can write displacement is 150 meters. So here distance is more, displacement is less. So this is the cases, in some cases it happens that distance may be more, displacement is less. So if it is a straight line motion, then distance and displacement may be equal in some cases. Okay, here we will see one or two examples in a diagrammatic way to understand better. Okay, see, if an object has moved in this semicircular position from A to B, it has moved in this direction. Okay, the distance, the radius of the semicircle is R. So here the distance covered is A to B. That means if the perimeter of the circle is 2 pi R, the distance covered is how much? 2 pi R by 2. This is the distance. And the displacement, what is the displacement? If this is the radius and this is the radius, the displacement is 2r. If this is the this is considered to be a circle, this is a semicircle. So this is r, this is r. So in this way, we should understand what is distance and displacement. Okay, and one more diagram where we can see what is displacement and distance. If an object is traveling along, see, along the sides of a triangle A, B, C. Okay, it has started here and it has moved to here and it has ended up here. So the starting point is A, the ending point is C. So here, if the sides having an equal length x, okay, it is an equilateral triangle, the distance traveled by the object is x plus x plus x. Okay, that is 3x. So the displacement will become the distance between the initial and final point. What is the initial point here? A, and the final point is C. The distance, the displacement is x. So this is the distance, this is the displacement. So these are the some of examples which we can understand the displacement and distance concept in a better way. Okay. So we move to, this is all about the displacement, distance, and if we add some time concept to this distance or displacement, we move to next, the definition of speed and velocity. So if, what is speed? See, speed. Okay, the distance traveled by a body in a particular time. Okay, if suppose the distance traveled by a body is here, the 200 plus 50, 150 meters, we are, I have already told you, we have seen in this previous example. Here if it is, if the distance covered is suppose in 25 seconds, okay, in 25 seconds it has covered a distance of 250 meters, then the speed will be, it is distance covered by the time. So in this way we can define speed as distance by time, distance by time. Okay, so here what could be the speed? 250 meters by 25, that is 10 meters per second. The unit of speed is meters per second in SI system. In CGS system it is centimeters per second. Okay, so here we have seen what is speed. So after knowing what is speed, we have to learn something about uniform motion. Uniform motion. Okay, what is uniform motion? See, uniform motion is an a traveling of a body, see, with respect to time, if it covers an equal distances in equal intervals of time. See, I'm again telling you, if it covers an equal distances in equal intervals of time with respect to time, if it is covering an equal distance, suppose 50 meters in some time t, another 50 in some same time, and another 50 meters in the same time, that is called a uniform motion. So here the speed is constant. In uniform motion the speed is constant. Okay, next, what is, after the uniform motion we have to go to that speed concept again. What is a uniform speed? What is uniform speed? Okay, see, if some body is covering a distance, it is covering a distance of equal distances in equal intervals of time, then we can say the body is moving with uniform speed. Okay, see, covering a distance, equal distances in equal intervals of time, then the body is considered to be moving with uniform speed. Then after this, what is non-uniform? Non-uniform speed. Okay, non-uniform speed, if it is covering at distances which are not uniform and in regular intervals of time. See, the distance covered by an object is not equal in equal intervals of time. He's that I'm see here, if the distance covered in a time t seconds is 50, and if the again the distance covered in time t seconds is suppose 150, and again in the next t seconds if the distance covered is suppose 250, then it is called non-uniform speed. It is moving with non-uniform speed. The speed is changing with respect to time. Okay, so non-uniform speed tells that the object is having the distance irregular distances covering in equal intervals of time. Or we can say that in the reverse, that in irregular intervals of time it is covering irregular distances, okay, in equal distances. In unequal intervals of time it is covering equal distances. We will show you how. See, if it is covering, if first 50 meters it is covered in suppose t seconds, and next 50 seconds in t2 seconds, next 50 meters in t3 seconds, that is equal distances in unequal intervals of time. Okay, so non-uniform speed. So after that we will move to what is average speed. What is average speed? See, the term average means it is telling something about the individual collection of the speeds in different times. So the average speed is the distances covered by the object in different times. Okay, that means we can say in another form the total distance covered by an object by total time. Okay, so this can be written as x2 minus x1 by t2 minus t1. See, where x1 and x2 are the position of the object moving, t2 and t1 are the times at which the object is there. At t1 the object is at x1, at t2 seconds the object is at x2. So the difference, the distance traveled in a particular time is called average speed. So if the distances traveled are n number of distances in n number of timings, suppose if s1 comma s2 comma s3 up to so on sn are the distances covered by the object in different timings t1 t2 t3 up to tn seconds. Here the average speed can be written as total distance traveled by total time up to tn. Okay, this is average speed. So by this what we know is at the entire distance it is traveling from a to b, from initial point to final point, what is the average speed? Suppose from here to some point it is moved with 10 meters per second, from there to another point it is moved with 30 meters per second, but on an average from a to b, from initial point to final point, what is the average speed? So that it tells the average speed of the object. Okay, Next, what is instantaneous speed? Instantaneous speed. See, the average speed is the speed covered by an object by in a time frame between 2 points. The instantaneous speed tells us the speed of an object at some particular instant of time. At some particular instant of time. See, if the average speed is taken into some time limit, so that the time limit is very small. Okay, in this way we can write delta t tends to 0, delta x by delta t. See, here the delta x represents the distance covered, a small distance in a short interval of time. Delta t is the short interval of time. Delta t tends to 0 means it may be very small, infinitesimally small. That means we can write it as delta t tends to 0. This gives us the instantaneous velocity at a particular time of instant. So this can be written as dx by dt. Okay, so dx by dt, the change in distance with respect to time, a small distance covered in with respect to small time dt. Okay, so this is about instantaneous velocity. So here we have seen some terms regarding the motion in a straight line. See, after that we will cover in the next class velocity and acceleration, some more terms which will be very interesting. While moving into the details of a straight line motion, we will be deriving some more equations of motion here. Okay, so we will see in the next class.